Hi, I'm David with Portrait Displays, and in this video, we're going to walk through calibrating the Sony PVM-X2400 with Calman. It's important to note that this process will also apply to the Sony PVM-X3200 and the Sony PVM-X1800. Let's get started. Let's launch Calman. While Calman's loading, let's take this opportunity to go through the menus on the Sony PVM-X2400. On the bottom, we have our menu, back, and select enter button. If I press menu, I can take the joystick and navigate through the main menu options on the left-hand column. If I scroll to the info page, I can select enter and see things such as the unit status, as well as the source signal coming in. You'll notice I'm running single link 12 gig SDI at 3840 by 2160, 2398, and we're sending 444 RGB 10-bit into the monitor. If we back out of the info page and come back up to the top, you notice we have channel settings. Think of channel as your preset or your memory. All the settings you see below the channel are going to be assigned to that memory. If we hit select enter, we can go through the memory and start configuring it. Right now I'm on 4K SDI input 1, which is where my test pattern generator is connected. As such, I'm going to leave it there. If we continue to come down, you'll notice VPID, HDMI auto, as well as SR Live auto. I encourage you to set these up in the best way that works for your workflow. I'm going to leave them off for the purpose of this video. We have RGB YCC range. Here, you would set your limited or narrow range, SDI full range, or full. I'm going to leave this in limited for the purpose of this video. Hit select enter again. Our EOTF is set to 2.4, and we're currently in ITUR BT2020. Because we're going to start the video by calibrating for SDR, I'm going to set the color space to BT709 because my target for the calibration is going to be BT709 at 2.4 with a limited range or narrow range signal. So hit select enter, choose BT709. We now have the ability to set our transfer matrix. Here you have two options, BT709 or BT2020. Because we're working in SDR BT709, we'll leave it set to BT709. The color temperature control is currently set to D65. I'm going to change this to user 1 so that I can customize the color temperature as we calibrate with our meters. Next, we have chroma, brightness, and contrast. Typically, I'm going to set these to the default settings to start. Let's set the chroma back up to its default of 1000. Brightness at 0 and contrast at 400. We'll press select enter to save our values. And now we have user LUT. We're going to leave this off and take note that there's a setting for the advanced preset down here. We'll go through that in a minute. As I scroll down the list, you'll notice that there's a copy. If you've already created a channel and you simply want to tune it, you could copy the channel to another memory and then just modify it. Think if you're calibrating for BT709 in limited range, but you also want a BT709 set to full range. I could copy the channel I calibrated, change the setting to full, and have a second channel I can toggle between really quickly between full and legal. Let's press the back button. Here we'll select user color temp. Now as you'll notice, we're in user color temp 1 since we chose user 1 in the previous menu. If we come down, this is where we would adjust our RGB gain and our RGB bias. There's one more thing here in the menu that you should be aware of. There's the signal setting. The Sony has two options. One, you can calibrate using an external generator like we're going to do here today, or two, you can choose the signal, change it to internal, and now use the built-in test pattern generator inside the Sony. If I choose my RGB gains, you'll notice a white window has now come up on the screen, allowing us to adjust using the internal pattern. I'm going to hit back, choose the signal again, and set it to external for the purpose of this video. Let's hit back, and now let's come down to advanced preset. On the advanced preset, you're able to adjust some of your SDI input settings should you need to customize them off of auto. But you'll also notice there's a setting for the HDMI format. Should you use the HDMI input on your display, the enhanced format is going to take full advantage of the HDMI's capabilities. If you have legacy products going into your Sony PVM-X2400, you can change this to standard format, which will give you more compatibility. Let's change it back to enhanced, press select enter, and let's hit back. Now if we come back out of the menu and we scroll down to System, and you press System Settings, you notice there's a couple more things. We're going to leave black detail mode off for the purpose of the calibration. The other thing that you may want to leave off is the dynamic control here. This control is going to modulate the backlight in an effort to increase contrast on the display. For the purpose of the calibration, we're going to leave it off. Let's menu out, and let's come back over to Calman. I'm going to come up to the top left corner in the Calman menu, select it, come down to Open Workflow Template, choose Calibration, and select Broadcast Monitor. To start, we're going to select HDR Calibration. Next, we're prompted to connect to our hardware. Here, I'm going to choose Find Meter, select COM4, and select Search. You may notice I'm using the Colorimetry Research CR300 and the Colorimetry Research CR100, the CR300 being a spectroradiometer and the CR100 being a colorimeter. What I've done before the shooting of this video is create a meter profile for my CR100 using the CR300. If you happen to be working in a workflow right now where you're going to profile your meters, you can check out our meter profiling video in the link below. We've now connected to the Colorimetry Research CR300. Let's press Find Meter and connect to COM7 for our CR100. Next, I'm going to want to open my settings panel. I'm going to leave my sync set to auto for the purpose of this video. We're going to come down to meter profile, and I'm going to select my meter profile that I made before the start of this video, the Sony PVM-X2400 made with the CR300. Next, we'll want to find our source. Today, I'm using the Virtual Forge connected to an AGA IO 4K Plus running SDI into the Sony PVM-X2400. So I'm going to come down to my taskbar, select the Virtual Forge, and now hit Find Source. You'll notice the manufacturer is SpectraCal, model SpectraCal Virtual Forge, and Calman has already found it on the network. I'll select it and press Connect. Now the third step in this workflow is to connect to the display. The Sony PVM-X2400 does not have DDC or direct display control integration with Calman. As such, we're not going to select our display, we're simply going to click Next. On this page of the workflow, Calman's asking us to set our calibration targets. I mentioned earlier in the video, we're going to target BT709 with an EOTF of 2.4 in limited range. Let's make sure Calman is set up as such. The white point, currently D65, color space Rec 709 sRGB, and our EOTF is set to BT1886. I'm going to change this to power 2.4. Let's click Next, and here we're going to take our pre-calibration capture. I'm going to navigate to the bottom right and press Read Series. Now you'll notice that my meters are slightly to the side on the monitor. The reason I have them placed that way is so that you can see the menu when we bring it up and what we're doing. I'm using a slightly larger window pattern than I typically would at about 25% image area versus the typical 10%. On this particular panel, that's not really going to matter given the calibration that we're performing, but just something to be aware of when you perform your own calibrations, that you'll typically want the meter in the center of the screen, and you'll usually set up for a window at 10%. Okay, our pre-calibration is completed, and as we see on the RGB balance, we're deficient in blue on our grayscale. Our EOTF is actually tracking that 2.4 pretty nicely. We're hitting a max luminance of about 93.5 nits, or candelas per meter squared. My target for BT709 is currently 100 nits. As such, we're going to want to correct that as we perform our calibration. The max Delta E2000, 11.2 on the grayscale. The average is 7. On our Delta E2000 for our colorimetry, we have a max of 11.3. Again, that's at the white here if you look below. And the colorimetry is actually not that bad when we look at the CIE 1976 chart. What we're mostly seeing is that shift because the grayscale is so far off, it's causing our secondaries to be out of alignment. Let's now go to the white balance page on the left-hand side. I'm going to select 100% and come over to the bottom right and choose Read Continuous. Here, we're going to set the white balance of the display and correct that blue error that we just measured in the pre-calibration. There's a couple things you can do here. You can look at the RGB balance chart and bring red, green, and blue into alignment. You can also use the XYY data chart in the bottom left to target 0.3127, 0.3290. Let's come back to the Sony PVM-X2400, press Menu. Now let's select User Preset Setting, come down to User Color Temp, hit Select, and now come down to the RGB Gain. Hit Select, and at this point we're going to be able to use the controls on the bottom as described here in the menu to adjust the red, green, or blue gain to balance this out. Right now it looks as though I need more blue, so I'm going to start with the blue gain. I'm going to hit F11 to select blue, and now I'll use my dial to adjust. Now you can look at the RGB balance chart, and you can also look at that XYY. Okay, at this point I have my X toggling right around my target of 3127, but I'm still off on my Y. I'm still high at 3325 when I want 3290. Because of this, I'm gonna now switch over to the green by pressing F10, and now I'll turn the dial to reduce the green. That has affected the balance a little bit, where I'm gonna wanna add a little more blue in. So I'll select the blue, bring that back up, and we're now at 3126, 38285, but we're only hitting that Candelas per meter squared, or nits, at about 92. So I'm going to want to bring the luminance up on this panel. So I'm going to select F12, and I'm going to adjust all three. I'm going to bring the RGB gain up in unison to increase the luminance. Now there's one more thing once you've set your RGB gains. You're going to want to press the select enter button so that the settings are stored in the display. If you hit menu or back, you're going to lose all of your work. At this point, let's back out of the menu. Let's come back over to Calman. I'm going to press stop on my continuous read. And now I want to choose the multi-point grayscale here over on the left. I'm going to come down, hit read series. Now the purpose of measuring the multi-point grayscale is because the measurement we just did was only at 100% white. It doesn't tell us anything about how the RGB balance is tracking and how we're tracking that EOTF curve. So measuring the multi-point grayscale is going to give us a little bit more information, and we're able to fine tune from here. Now our multi-point grayscale is completed. If we take a look at the RGB balance, we're tracking really nicely throughout the range. Our EOTF is tracking our target curve, and if we come down to the data grid and scroll over, we're still hitting 100 nits. It looks like our Delta E2000 has a max of 0.7 with an average of 0.4. This is tracking excellent. Let's now take a look at our color space setting by coming over to the left and clicking on color space setting. Let's come to the bottom right and hit read series. Now what this is going to do is measure the outer edge of the gamut. It's a quick way for us to ascertain if we're in the right color space or if something went wrong. As you can see, we're hitting the RGB yellow, cyan, magenta targets here on the CIE 1976 chart. And if we come over to our Delta E2000, we have a max error of 0.8 with an average of 0.4. It looks like we're in BT709 and the gamut mapping is as we expect. Let's come back to Calman, and let's now do a couple additional validations. Let's check the color checker. Let's hit read series. Now the color checker is not only going to do the edge of the gamut, it's also going to do a number of colors inside the gamut so that we can have a better idea of how flesh tones and other colors in nature are going to be representative on the display. Okay, so the color checker is now finished, and as you can see on the CIE 1976 chart, everything seems to be hitting its target. If we come down to the Delta E2000 chart here in the bottom left, we'll notice our max error is 0.7 with an average of 0.4. If we would like to do even further validation, we can come over to the left, click on saturation sweeps, and press read series. Okay, our saturation sweeps have completed. As you can see once again on the CIE 1976 chart, we're hitting our targets. And on the Delta E2000 chart down on the bottom left, we have a max 0.8 with an average of 0.3. The Sony PVM-X2400 is performing excellent against our BT709 2.4 limited range target. Let's come back one more time and take a post-calibration capture here in the workflow. Select post-calibration capture, come to the bottom, and press read series. Okay, our post-calibration capture has completed. The RGB balance is tracking excellent. You'll see a small shift near black. Once again, that could be a little bit from the ambient light in the room. It could also be a little bit of the backlight leaking through, going just a little bit blue, as is typical with a lot of LCDs. The EOTF is tracking excellent. We're hitting our target of 100 nits. And our Delta E2000 on the chromaticity, max 0.8. with an average 0.4, and our Delta E2000 on the RGB balance is a 1.1 with an average of 0.4. Let's now take a look at those pre-calibration readings on our pre-cal capture page. We came from a Delta E2000 on the RGB balance with a max of 11.2 and an average of 7. and the chromaticity delta E2000 from a max of 11.3 and an average 3.7. Significant improvement from the pre-calibration to the post-calibration capture here. Now there's a couple things I might do when I finish my calibration. One of them, to make it easier for my operator, is going to be press menu, select channel setting, come down to name, and change the name of the channel so it makes sense for what we optimized it for. So now we have BT709_2.4_L for limited. The next step, if you'd like, is to back out of the menu, come down to the function button settings, and you can also assign this channel now to an F key, so the user might quickly bring it up simply by using the F keys on the bottom. Right now, channel 1 is currently set to F1. If we come over, select F1, you'll notice we just brought up BT709_2.4 limited. That's our SDR calibration, but what about HDR? Let's do a quick walkthrough on how you'd calibrate the HDR mode on the Sony PVM-X2400. I'm going to come back to my workflow and choose Welcome. Next, I'm going to press HDR calibration. I can skip over connecting to my meter and my pattern generator since I'm still connected. And let's come over to calibration targets. Now for the purpose of this video, let's calibrate to P3 D65 PQ in limited range. So I'm going to set up my calibration targets for white point of D65. I'm going to change my color space from Rec 2020 to DCI P3, and we'll leave the EOTF at ST24 HDR. Now my next step here is going to be configuring the Sony PVM-X2400 for the same target. So let's press menu. I'm going to select user preset setting, select channel setting, and now I don't want to mess up my BT709 memory. So I'm going to change from channel 1 to channel 2. At this point, I'm going to go down my menu. I'll leave it in 4K SDI input 1, VPID off, SR Live Auto off, RGB YCC range will be set to limited, our EOTF will be ST24. I'm going to change my color space from BT2020 to DCI P3. We'll set the ITU BT 2020 matrix to 709. Now I'm working in RGB, so this is going to matter. But most systems in production and post-production today utilize the BT 709 matrix when outputting P3 D65. As such, I want to make sure the Sony monitor is set up exactly the same. We'll take our color temp, and I don't want to overwrite user 1, so I'm going to set this to user 2. Chroma, brightness, and contrast at their default. And again, we are still in that advanced preset 1. Now let's menu out and let's come back to Calman. We'll hit next, and now we have our pre-cal capture. I'm going to come up to history 1, right click, and hit clear tab data. Press OK, and now we're starting with a fresh data set for HDR. Let's hit read series. Okay, our pre-calibration capture is completed. Our RGB balance is tracking pretty good. It can be improved. We have a little bit of green on the top end. We're going a little minus red. Our EOTF looks like it's tracking just under the PQ curve. If you look at this great measurement line against our yellow target line, same thing on this bottom luminance chart here, you'll see we're tracking just underneath that PQ curve. We're hitting a max luminance of about 891 nits, and our delta E2000 has 3.1 max with an average of 1.7 on the RGB balance, and our chromaticity has a delta E2000 max at 1.9 with an average of 1.7. So let's click on over to the white balance. And now we're going to do a similar process that we did for SDR. We're going to choose white, and we're going to hit read continuous. Now let's come over to the Sony display, press menu, come down to user color temp, hit select, come down to RGB Gain, hit select. And now at this point, I'm going to choose F9, and we're going to start with that red. We're going to bring the red up to match that green on the RGB balance. I'm going to bring red up to match that green. And now let's press F11, select the blue, and bring the blue up to match the red and green. Okay, so our RGB balance looks pretty close, tracking against that 100 target line. And our XY values on the bottom left are tracking 3127, 3287 at 884 nits. Now, let's press stop. And let's not forget to hit select enter to save our values, press menu to exit, Now let's come back over to the multi-point grayscale, come down to the bottom right and hit read series. Let's see how well the multi-point grayscale is now tracking. My intuition tells me we're probably still going to be a little low on that PQ curve and we're going to have to make some more adjustments. Let's take a look. Okay, as you can see, the RGB balance has been flattened out quite nicely, but if we look at the EOTF and luminance charts, you'll see the gray measurement line tracking under the yellow target line on both charts. What that tells me is that we're not quite tracking PQ as nicely as we would like. We can also see that we have a delta E2000 error with a max of 2.5 and an average of 1. If we come down to the data chart and look at 50%, you'll notice we're measuring 83.9678 nits with a target of 94.3784 nits. So we're measuring a little low compared to our target. Let's select 50% and let's now come over to the read continuous. At this point, I'm going to go back into the Sony display, press menu, hit enter under user preset setting, come down to user color temp, hit enter, come to my RGB gain, press enter, and now we're going to want to hit F12 to select red, green, and blue. And now let's turn these up to increase the luminance. We're going to look at the Y on our data chart for 50%, and we're going to bring the Y up to match that target of 94 nits. Let's press select enter to save our settings, and let's press menu to exit the menu. Now I'm going to come back over to Calman, press stop, and now let's hit read series. This is an often overlooked part of HDR calibration. The SMPTE SD28A4 or PQ curve is an absolute curve. Each bit level equals a specific nit level. So we want to make sure we're tracking that curve as accurately as we can because most content that's being produced today lives at that 200 nits and under. As we go higher up in the nit level, less and less content is going to be hitting those higher ranges. So it's really important to get those lower nit levels accurate so that the majority of content is going to look as it should. Let's take a look at our results. The multi-point grayscale is still tracking the RGB balance very nicely. We can see on the EOTF curve that the gray measurement line is tracking the yellow target line very nicely, and we also see the same thing on the luminance chart. If we look at our delta E2000 error, we have a max of 0.8 with an average of 0.3. We're now tracking up to 980 nits, much brighter than we were before. Let's now take a look at some additional validations. Let's choose the color checker here on the left. Let's come down to the bottom right and press read series. Okay, so our color checker is completed, and as you can see, for the most part, we're hitting our targets. There are a couple things maybe slightly undersaturated. This now could be partially because of the ambient light that's coming in the room. Could also be panel performance. We look at the delta E2000 chart. Our max error is 1.2 and our average is 0.5. Still very, very good results. If we want, we can hit next and do some saturation sweeps. Let's take a further look and see how saturation is tracking. I'm going to come up to the history one, hit clear tab data, and press read series. Okay, our saturation sweeps have completed, and if you look at the CIE 1976 chart, we're tracking very, very well. We have a little undersaturation in the red, as we saw on the color checker chart, and it looks like a little bit on the magenta. But if we take a look at the delta E2000 numbers, we still only have a max error of 1.2 with an average of 0.3. Very good results. Let's come over to the post-cal capture, right-click on history one, clear the tab data, and let's hit read series. Okay, as you can see from our post-calibration capture, the RGB balance is still pretty flat. We're tracking that EOTF line, we're hitting that 982 nits, and our max delta E2000 is at 0.8 on the RGB balance with an average of 0.3. Our delta E2000 on chromaticity is a max of 0.3 with an average of 0.2. If we take a look at that pre-cal capture, we've improved from a max of 3.1 with an average of 1.7 on the RGB balance and a max of 1.9 with an average of 1.7 on the chromaticity. And we're tracking that EOTF curve much better, and we've brought it up from that 891 nits to that 982. Now there's a couple more things. The Sony PVM-X2400 is an LCD panel. As such, we can come back into the menu, come down to that settings icon, the gear icon, select it, and if we want to, we can come over and turn this dynamic control on. Now this is going to improve the contrast of the panel, but it may limit the max luminance of HDR. So be careful when you use it, but if you are looking to achieve more contrast, the dynamic control is going to help you do just that. For now, I'm going to turn this back off, and I'm still going to want to set up the display for my user. I'm going to come back up to the user preset setting, select the channel setting, come down, and now name my channel. I've now named the channel P3D65 PQ Limited. I'll press Select Enter on the done. We'll see P3D65 PQ Limited, and if I want to, I can press back again, come down to the function button, change function 2 to be channel 2, and now my operator can choose function button 1 for BT709 2.4 limited, or function button 2 for P3D65 PQ limited. And that's how you use Calman to calibrate the Sony PVM-X2400, the Sony PVM-X3200, or the Sony PVM-X1800. We hope you enjoyed our video. We'll see you on the next one.